Plate Tectonics, the Shifting of the Earth. Colorado State Standards 3.1 Earth Systems. Major geologic events such as earthquakes, mid-ocean ridges, volcanic eruptions, and mountain formation are associated with plate boundaries and attributed to plate motion. Evidence-based outcomes for the lesson. Gather, analyze, and communicate data that explains Earth's plates, motion, and results of motions. Identify, interpret, and explain models of plate motions on Earth. Use maps to locate geologic hotspots using evidence of earthquake and volcanic activity. And use web-based or other technology tools to show connections and patterns in data about tectonic plate boundaries and earthquakes, volcanic eruption, and mountain formation. This website includes interactive activities for math and science and has one for plate tectonics that students can use, and it looks something like the following picture. First, students can choose what type of crust they want to work with, and you can see we have continental crust and two types of oceanic crust. And once they've chosen and put them into the dotted lines, they can manipulate them. So here you can use a lever to see what happens when you merge oceanic plates with continental plates. They subduct. And we can also use two oceanic plates, pull them together and see what the overall result is, which you'll see here in a second. And you can see that the mountains are forming because the land is colliding and moving upward. So hopefully students have a chance to navigate and explore these different plate boundaries with this program before we move into the lecture. That way they can create a mental picture as we move forward with terminology and some more complex concepts. For the lecture portion of the lesson, we'll dive into more technical terminology that's involved with plate tectonics, and we'll discuss the differences between converging and diverging plate boundaries. We'll talk about what subduction is, and we'll talk about what transform faults are, among others. And I'll have students actively model these different plate boundaries on the interactive software, so that way they can see it, work together to help each other understand it, and then they'll document all of the results in their journals, so that way they can take them home and study. For the assessment portion of the class, students will build a model of the Earth using styrofoam balls, and then they'll draw the plate boundaries that exist across the Earth. And from here, they'll research three specific major Earth events that have been caused by the motion of plate boundaries, and give a brief presentation to the class about what they found and how they happened and what the result was. The goal of this lesson was to incorporate technology. I think that by using the interactive software program, students will have fun, be engaged, and it'll be student-directed learning rather than teacher-directed. Also, students will participate in research, which is a highly relevant 21st century skill that all students need to learn. And to help solidify and reinforce all of the learned material, students will be able to use their hands, build models, which stimulates creativity, and present their work to their classmates. All of these factors, I think, will make for a very effective and successful lesson.